This video is sponsored by Rewarded View. Are you tired of just scrolling through your phone without making any profit from it? Well, Rewarded View is for you. If you have an Android phone, then head over to rewarded-views.premier.ai, download the app, and start earning today. All you have to do is create your accounts, watch videos, and get paid for each and every video that you watch. So what are you waiting for today? Download Rewarded Views and earn the smart way.
Hey guys, how y'all doing? How's your day going? I'm just starting out your night. Hope you are having an amazing and beautiful day today. So finally we have entered Python for data science, and today we're going to be touching a very important um model called NumPy. In our last video we introduced you to models. If you are not familiar with it, if you need further guidance, you can always head over to my YouTube for detailed tutorials. But yeah, when you're working with NumPy, the first thing you would need to do is install it. Before we jump into what is NumPy, NumPy stands for numerical Python. It's a multi-dimensional array library used for numerical computing. You can use it for when you want to start working with things like statistics, linear algebra, and when we start working with more complex things like scikit-learn, you will see NumPy functions like shape making an appearance again. So the first thing you need to do is go head over to your command prompt or your terminal and do pip install NumPy. Then after you're done with that, you can head over to your text editor, to your file. If you're using Jupyter like I am, then just head over to Excel and pass in import NumPy as NP. We talked about importing models in our last video. So do that. If you want me to do a tutorial on how to use Jupyter, let me know. But yeah, import NumPy as NP. Once you've imported it, the next thing you would need to do is to initialize the array. That's creating a new array. Now there are multiple types of arrays you can create. You can create a one-dimensional array, which is more of just like a basic vector, just a casual list. So, but when you're creating an array, it's the same command np.array parentheses, and then you have your array. You list out your array you want to do. So if you are doing a one-dimensional array, we're going to just say np.array parentheses, then in the brackets, just our values. That's how a one-dimensional array looks. If we're working with two-dimensional arrays, it's going to become like a nested list. So we're going to have the first and the main list that everything is held in. Then we're going to have two new lists within that list. So like I've noticed like a lot of people will just put list number 1 and list number 2. No, you have your main list and you nest those lists in between it. And a 3D array is going to be, you have your main list, then you have two lists within the list. Then within the two lists, you have two more lists, and within the second one, you have two more lists. And it just goes on and on and on and on, and you can have as many dimensions as your heart desires. Now let's visualize it. So we've created the array. Now I want to view the size, want to view the size, the shape, stuff like that. So if you want to get the dimension of an array, that is like what I just finished explaining just now, like we have one dimension, two dimension, you just do this by doing ND, that is number of dimensions, and it's going to give you how many dimensions there are. If you want to get the shape, this kind of like how many rows. So the first one is going to be rows, and second one is going to be columns. So a lot of people might mistake this, but row is the one that runs horizontally, I think, and columns is the one that runs vertically. So for our first one, A just has one row. Sorry, A just has one row and a bunch of columns, but remember A is a one-dimensional one, so it's treated as a vector, so you don't address it the way you would other one. So it's just going to list out the total numbers of columns that exist there, which is 4. B on the other hand though, B has, let's go to where we printed out B. So B has 2 rows and 3 columns, so it's a 2 by 3 matrix. And C has, let's see it here. So it has 2 main rows. Then within those 2 rows has another set of 2 rows, and each of them in total have 3 columns, which is what we have here, 2 by 2 by 3. Now, if you want to get the data type and the memory size, you just do a dot d type, which will give you int32. Now this int32, if you come over here, so when you're working with storage, yeah, you should be familiar with bits and bytes. So 8 bits, or in this case, I think it's 32. That let me just close all this stuff. Sorry. So in this case here, we have int 32. So it's just saying that we are using 32 bits, which in total is 4 bytes, which representation is going to be like in memory placement is going to be 1, 2, 3, 4, all of which individually hold 8 bits. So if we have a number, like let's say we have a number 1, 1 is just going to be, since this one is 32 bits and it was holding 1, just going to be 1, which is an excess amount. So usually when you want to initialize your data, you would want to specify the amount of uh, you want to specify the amount of memory space it should occupy. To do this, what you just do is the normal np.array, call your array, and then you put a comma, d type equals to int, which is the data type, and 16, which is the total memory it should occupy. Array NumPy is very, very straightforward thing. If you want to get the total size in bytes, which you just covered now, you just do 8 as item size, which is going to give us 2 bytes, that is 16 bits. If you want to get total elements that exist within it, so you just do a dot size. If you want to get the total number of bytes, that is, so this size of bytes here is just going to give us, like, for each element in the array, this is the amount of bytes that they occupy, right? So if you want to get the total number that is being used, that is for each individual element in the cell, they are all going to occupy a certain amount of bits. Then you, like, since, okay, for an array with 3 elements, it's going to occupy 2 bits each, so it's going to be 2 by 3, like 2 times 3, sorry. So if you want to use a normal formula, you're just going to a dot size times a dot item size, or even to use a general command that has been created to assist you with that. You use n bytes, that is number of bytes. Modifying elements. So if you want to modify an element in an array, this is just making certain changes to the elements that exist in that array. Sorry, I'm just trying to keep everything organized. First thing you need to how to do is to access an array at access an element at a specific index, which is very easy. So all you have to do is just almost like the way you would if you were working with lists. So you can make reference back to list. So it's going to be, first of all, the name of the array or the name of the list you want to access. Let's use B. Then it's going to be at what row is it found. Let's use 0, which is the first. Remember when I talked about indexing in our 2 videos ago, indexing in Python starts at 0. So it's going to be 0, and then the column, let's just use, so I think B has up to 2 now. There are 3 elements in B, so yeah, it should have up to 2. And it's going to print out that element for us. Let's just see what B looks like. So be sure we got the right thing. So we say carry from the first row and carry from the third element. So that is here, 3. Next, if you want to get a full row or a full column, if you want to get a full row, you just do 0, which is the row you want to access, and you just put this column that access, just print out everything, print out all the columns under that row. That is, therefore column is the same thing, but you put the column at the row and you now choose the column at which you want to get everything. For very, very straightforward. If you already understand, please. If you want to change the value, it's going to become like the same thing. You're just going to make reference to the index, which is what we just did here, and you now equate it to the new value that you want to replace it with. So we're changing this value 4 to 4. So we want access for 4 is on the second row, that is 1, at the first column 0, that is 1, 0 equals to 44. And yeah. Now if you want to initialize different types of arrays, there are multiple ways you can go about this. Let's say you want to initialize an array that has all its value equal to 0. We just do np.zeros, and here is going to be the shape, that is the row by column. Don't forget to enclose that in the parentheses and place that parentheses within the new parentheses. So it's double parentheses that here. So we want a 5 by 3 matrix that all the values are zeros. Same thing for 1. So if you want everything for 1, it's just going to be np dot ones and the shape of what you want it to be. If you want to be a specific number though, this is where it now gets a bit different. So you can either use np dot full. Then here's first is going to be your shape, and second thing is going to be the value that you want everything to be. Or you want to use the shape of an already existing array, you're going to say np dot underscore like brackets the array that you want to use its shape and the value you want. Or you can do np dot full bracket a dot shape comma the value you want it to replace it. Now for generating random decimal values, there are two ways to go about it. First one is using np.random.rand, where you just put the shape of what you want the decimal to be. But if you want to copy the shape from an already existing matrix, you just put np.random.random underscore sample in parentheses a dot shape. You want to generate an identity matrix. An identity matrix is a square matrix that is a 2 by 2, a 3 by 3, just the row is equals to the column. So it's a square matrix where the main diagonal that is across like this is equal to 1 and everything else is equal to 0. So if you have the MP identity equals to 4, so we're saying wants to be 4 by 4, since we don't need to do like 4 comma 4 because it's a square matrix. So if it's 4 here, it's 4 here, it's 4, and the main diagonal is going to be equal to 1. I was trying to highlight across the diagonal, I forgot. The main diagonal is going to be equal to 1 and everything surrounding it is going to be equal to 0. If you want to repeat an array, so now when you now start coming to the vector, like this, when you now start need to consider like the size of the row, size of the column. So we have B here, and which is a 2 by 3, and you want to repeat that, is like just print it out a certain amount of time. So we're introducing to things called axis. So axis allows you to print either along the row or along the column. So when you say b equals to b comma 3, so once you repeat this b array 3 times along the axis 0, so it's going to just print the first row 3 times, print the second row 3 times. But if you now say you want to print across one where the axis equals to 1, it's going to first take each individual element. So it's going to now start going through it across the column and be printing it until it reaches the last element, following it like this. Do you understand? Now, working with some math equations. So first, your basic arithmetic. So you do things like b plus 2, b minus 2, etc., etc. You're just going to add b, in this case, add 2 to every individual element of the array in B. But if you want to now do matrix to matrix manipulation, where you want to work with things excluding multiplications, we're going to visit multiplication later on in the video. But when you want to work with things like addition, subtraction, the shape must be the same because it's going to have it like side by side. If you have done matrices before, you should be familiar with this already. But we have it, so we have it by side. So it's going to be the first, let's say, so we have 0 by 1. So that is like let's say A01, B01. It's going to add it together. A02, B02, add them together. So you need to like have enough elements, equal elements, that you can add everything together. Then we have linear algebra. This is a branch of maths concerning linear equations such as linear maps and their representation in vector spaces across matrices. So if you want to multiply two matrices, which is why I see we're just going to touch now. If you have done matrix before, you should already be familiar with this. If you want to multiply two matrices, the column of the first one must be equal to the row of the second one. So like I gave an example here. If you have A R1, C1, and B R2, C2, C1 must be equal to C2. Usually, the way that I just remember it is like if I write out the shape of the first matrix and the shape of the second matrix, the ones that are touching, which is obviously going to be the column of the first one and the row of the second one, should be the same number. So where the two of them touch, they must have matching numbers. So if you have our two arrays here, if you guys don't know how to do array multiplication, I think I should have like a place where I was solving it. I wanted to share, but my handwriting is even trashy, so would you guys will be able to do it? You can go and watch. There's so many videos out there about matrix multiplication. But if you want me to do like it should do like a video on matrix, let me know. Okay. addition of matrices, scalar multiplication, that's when you're multiplying a matrix with like an individual number, kind of like what we touched on earlier. The multiplication of matrices. So it's going to be a long thing. I don't know if the camera is going to show it for you, but I kind of like used graphics. Forgive my notes. I kind of use graphics so you understand the way the matrix multiplication works. So, gosh, hopefully you're seeing this. So, giving A and giving B. So you have, so first thing you're going to do is you're going to say pick these first few values of A, which in this case is 3. Should we, is there a way I can do this? Let me find a way. There's always a way to do everything. We are going to do matrix multiplication now. Okay, forgive me. So I'm not very good with using mouse to paint, but just bear with me. So let's say we have A is equals to 3, 1, 4, and B is equals to, so this one B must have three rows. So we'll say 4 and 3, we have 2 and 5, and we have 6 and 8. So the way I just think of this calculation is going to be, we're going to have run along this axis like this, multiplying it with its element along like this. Do you understand? So we'll take each element following along this place like this and multiply them across these ones like this, adding each of them together. And in turn, it's supposed to give us a new matrix, which is going to be, so we'll take this, which is going to be equals to the total columns that this one has the by the total row that this first one has. So in this case, this one has um 2 columns, but A has 1 row, so it's going to be 1/2. So, this shit. So let's get into the main matrix. Is there where I can increase this stuff? Whoosh. That'll just zoom it in here. Let me just cut out. Let me just cut out this. Okay. So the first thing we're going to do, like I say, take it. So we're going to say, remember I said we're trying to get a matrix that has 2 columns and 1 row. Say 1/2, technically just a vector matrix with 2 columns. First what we're going to do is take this very first value here. So it's going to be 3. And we're going to multiply 3 by, remember I said we're running across 3, so I'm multiplying 3 by 4 plus we're taking 1, multiplying 1/2, and we're taking 4, multiplying 4/6. Why did the size become so blunt? So everything in total, so these are our new matrix that we're going to get. So once we carry out all these things, it's supposed to give us what is going to be here. So 3/4 is 12, 13, 14, 6/6 times 4 is what, 24. So we have 24. Oh shit, my math. Hopefully I'm correct, but this should give us 38. Then we're going to repeat the same thing. So let's just cut that again. Last night I made love in the city. We're going to carry 3. Multiply 3. What value is this? 3. Multiply 3/3 plus 1 by, hopefully that is 5, plus 4/8. I know, just do the math by yourself. Whatever value you get, put it here where x is. And that is how what we're trying to do. Matrix multiplication. There's a what they call it. There's something they call multiply matrix and matrix. Whatever they call it, yeah, that's what we just did there. Bravo, brava, unsafe, tell me that. So long story short, yeah, should I have just solved this one? You know, attempt it yourself. Either ways you do mp.matmul parentheses, the two matrices you want to make sure the one you're putting first is the one that just determinants and the formula stuff. So let's use this one. So we have an array 5 by 6, 7, 8. Let's go back to paint. 5 by 6, 7, 8. So we have 5, 6, 7, 8. So the way determinant works, you just have this here, you have this here. It's going to be 5 times 8 minus 6 times 7. Yeah, it's very straightforward. Do the math yourself. It's nice and I'm really tired. But when you add everything together, when you do everything together, the with arrays with NumPy, it's just going to be np dot linear algebra is linalg dot dt determinant and the matrix you want to get determinant for and it's going to generate that value for you. Now let's go into things that are more statistically oriented. You want to find the minimal value, you just do np dot mean and the array and give the general minimum value by row. But if you want to find the minimum value row by row, you just say np dot mean axis 1 if you want to get it, column by column axis 0. If you want to find the max by, why did I put mean here? It's max, supposed to be max. So it's the exact same thing as mean, just change mean to max. If you want to find the mean, like the average, you do MEN, np.men, and where you want to get from. You want to get the standard deviation, you do .std. We're going to visit this a lot where we start working with machine learning. Then percentile, you just do it's I don't if you want me to the detailed video of statistics, let me know. But you can just go and read on percentile. So it mustn't be 80. You can find the 60th percentile, you can find the 7th, just it depends on you. Now if you want to sum elements, you just do np dot sum and sum everything together. If you want to sum across the column, you can do this one, sum across the array, across the rows, you can do axis equals to 1. Now reorganizing an array, this should have probably placed under modifying. But if you want to change the shape, one thing you must know is that the total amount of elements of your current shape should be equals to the total amount of elements for the new shape you want to create. That is, if you want to get, so let's say we have the shape of S, to get the total elements, it's just going to be 4 times 2. So if you want to create a new array and change to a new shape, we'll just do that shape, multiply everything, the shape. For example, here, I want to do a 3D one, so I want to do 2 by 2 by 2. Just do 2 times 2 times 2 is giving us 8. 2 times 4, 8. So that means it's going to fit in perfectly. If I were to mistakenly do like a number that was not going to fit, it's going to generate an error, which we do not want. So whatever you're doing, make sure the shoe fits. Then stacking, you can either stack vertically or horizontally. If you want to stack two elements vertically, you just do W V stack, comma, bracket, square brace, the two things you want to stack, and just going to place them like I will place the other one below the other. But if you are stacking it horizontally, it's not going to like just be picking out the elements and just make it like it's like a straight. If you want to generate a random amount of variables within a range, kind of like generate random decimals, but what you just do is you just say np dot arrange, that's arange, your starting value is 0, the ending value, this is obviously going to be n minus 1. So if you want to end at actually end at 20, you're going to put 21 instead. Like if you see in this case, when I put 20, it ended at 19. If I put 21, it's going to be ending at 20. Then this one is the skip value. If you want to like jump every after every other element, you just put that. Then if you want to shuffle an array, you just use permutation. So is the chance of you seeing it change, like I have to shuffle it multiple times for this one to move up. So it's just randomizing it. So the more elements you have to shuffle, the more it's going to shuffle. But it's going to treat this one as its own array, treat this one as its own array. So it's not like shuffling in between values. You just push this one down, push this one up, push this one down, push this one. Lastly, let's touch working with booleans. So if you just carve like the way it was when we're working with normal arithmetic, you do b greater than 2. Wherever is false will show false. But what if you only want to show where it's true? So you put b brace b greater than 2. So it's going for every element in b, show where b is greater than 2. That's what I just saying. So it's going to show the individual values where b is greater than 2. You want to check if at least one is true. You just say mp.ne b greater than true. So if any at least one of the elements is true in the whole, so it will return true. You can do this column by setting the axis equals to 0, and you can do row by setting the axis equals to 1. Same thing goes for if you want to check if every single thing is true. You can do mp.all, mp.all by axis. And yeah, that is some of the basic stuff you need to know for NumPy. As we start progressing, we're going to be making more references to it, but this should kind of like get you going. So yeah, if you have any questions, you can scan the QR code. Is always available for you. Peace out.